Very good morning, students. So this is our next tutorial on the same chapter, electrostatic. In the previous video we have discussed few subtopics of this chapter. We have come across what is charge. Charge was an intrinsic property of an atom which creates a force. Similarly, a charge, when it is placed in an air or vacuum and another test charge is brought near to it, we have seen there can be electrostatic force of attraction or repulsion. So this was based upon Coulomb's law, which states that electrostatic force of attraction or repulsion is directly proportional to the product of the charges and inversely proportional to the square of distance between them. So whether these charges are placed in air or vacuum or in a given medium, it depends upon permittivity. The formula which we have seen in Coulomb's law was F equals to 1 by 4 pi epsilon naught Q1 Q2 by R square. This epsilon naught is considered to be as permittivity of free space. Permittivity of free space, which indicates that whether the two charges are placed in air or vacuum. Now, in case if that two charges are placed in any other medium, let us consider water or glass, then this epsilon naught will get changed and we will consider that K epsilon naught, that means ER, that is relative permittivity, and K is considered as dielectric constant. So these all things we have seen in the previous video. Also we have seen that if a test charge is placed and it creates a surrounding, an influence around it, that means if you bring any test charge, then whether it be attracted or whether it be repelled, and the strength of the electric field is determined by the electric lines of force. These electric lines of force are imaginary curve which originate from positive terminal of a charge and it gets terminated to the negative charge, and any tangent drawn on the point of the imaginary curve gives the direction of electric field at that particular point. And these electric lines of force, they don't intersect each other also. If they intersect each other, we have seen, then there will be two electric field direction at that particular point of intersection, which is not possible. So we say that this electric field is a vector quantity and it originates from positive and terminates to negative, right? But you see, when I say that sketch a diagram for positive charge and a negative charge, it's electric lines of force. Then for positive charge, always the electric lines of force will be away, and for negative charge, let me make it clear, and for negative charge, electric lines of force are always towards. So by looking the arrow direction of electric lines, you can easily find it out whether it is positive charge or negative charge. So in this video we will learn that what is the amount of work done in bringing a test charge from infinity to a given point where a source charge is placed. Yes, I am talking about electrostatic potential. So what is electrostatic potential? Potential gradient, equipotential surface, electric flux, and the Gauss's law. So these are the subtopics we will be discussing in this video. So let's see one by one. So here we will see that what is electrostatic potential, right? Suppose we have one a positive charge, source charge, and a test charge we are bringing from infinity. When we bring any test charge from infinity to a given point under the influence of the source charge, we'll find that there will be some force of repulsion if both the charges are of same nature, if both are positive. So that amount of work done to that of test charge is said to be as electric potential. So electric potential at any point is equal to the work done per positive charge. That means work done per unit positive charge in bringing it from infinity to a given point under the influence of a source charge without acceleration we consider to be as electric potential, and formula we say that V equals to W by Q0, where W is the work done in bringing a positive test charge to that of unit positive charge. SI unit is joule per coulomb and it is a scalar quantity. Now we will find the expression. You see, we know work done equals to force into displacement, right? Force into displacement. Now V equals to W F into, let us consider R, and we know F equals to 1 by 4 pi epsilon naught Q0 by R square into R. So this is the force and this is the displacement, right? So here when we 1 and 1 are got cancelled, so this is our V. Now when total work done by test charge, right? So here this total term will be divided by Q0. Now Q0 and Q0 got cancelled here. So potential equals to electric potential 1 by 4 pi epsilon naught Q by R. So this is our final expression, right? So here we know that electric potential is work done per unit test charge. In work done, we have used this formula, force into displacement, and force is nothing but a Coulomb's force between a test charge and the source charge. So when we include that formula, we see that R, small r and small r got cancelled, and Q0 and Q0 were cancelled. What is the small r? Small r is the distance between the test charge and the source charge. Potential gradient is the slope of that potential, if we say. Gradient generally when we say, that is, what is the potential gradient here? That is dV by dr. dV is the potential, electric potential, and dr is the change in distance between the source charge and the test charge. The rate of change of potential with distance in electric field is called potential gradient. That means simply it has written here that potential gradient means dV by dr. That dV means change in potential to that of change in distance. So V is the volt, means here potential unit is volt, and dr is the, it has unit of meter, that means volt per meter is the potential gradient, right? SI unit. Now what is the relation between electric field and electric potential we find here? This generally it is being used in a numerical several times. In the boards also they ask the relation between electric field and electric potential indirectly in form of the formula, in form of this numerical. Now electric field and potential gradient is said to be E equals to minus dV by dr. You see here negative sign is being placed because of the direction. Like when you are bringing any test charge from infinity to a given point without acceleration, you see you are bringing it against the electric field. Okay, so if the source charge is positive and test charge is also positive, when you are bringing towards the source charge, always there will be a force of repulsion. So due to this force of repulsion, there will be a loss of energy, there will be a loss of work done. So due to this, a negative sign is being placed before the expression dV by dr, which is the potential gradient, right? That means negative of potential gradient is the electric field. So this is the final relation. Flux. Any substance which has an ability to flow can be considered as air flux. Now, if you place a positive charge in a medium, and that positive charge will create an influence around it, that is the electric field around it, and we can determine that it has produced an influence or electric field around it by knowing or by experiencing its force of attraction or repulsion while bringing a test charge. And we can sketch the electric field by drawing the electric lines of force. Those are imaginary. Yes, so this electric flux, when I say, that means this positive charge is producing an electric field around it. So how many number of electric lines of force departing from that positive charge is considered to be as electric flux. Here we say that electric flux over an area, so this is, if you consider this is an area having S, total area is S and ds is the elemental surface, is equal to total number of electric lines of force crossing this area. So if the total number of electric lines of force crossing a surface area is considered to be as electric flux, because electric field lines is coming out of a certain area where the positive charge is placed. Now if I say this surface we have in terms of Q, in terms of Q, a surface is made up of, and inside that surface I have placed a positive charge. Definitely the electric lines of force will be emerging from each side of the Q. So we will say that total electric lines of force emerging out of the Q is the electric flux. Okay, that one we will calculate with the help of Gauss's theorem. Okay, here we see that phi E equals to EDS. So this is the formula of the electric flux. Phi is the flux, and what type of flux it is? Electric field. In the further chapter we will find that there is also magnetic flux, where magnetic field lines are coming out of a certain area. That one we will consider as phi M, right, or phi B. But here phi E equals to EDS, where E is the electric field and ds is the area vector, and SI unit is Newton meter square per coulomb. Equipotential surface is an imaginary surface which is created due to a positive charge or a negative charge. We know that whenever a positive charge is placed in a space, it will create an electric field around it, and this electric field can be determined by seeing its electric lines of force. And if the number of electric lines of force is maximum, we consider that electric field strength or electric field is maximum. If number of lines is less, then we say that the electric field is weak. Before seeing the note, if I consider here a source charge and it is creating an electric field around it, as it is a positive source charge, so electric lines of force, it will depart from the positive charge. It is departing here, and if the arrow direction is towards, then we consider that source charge to be as negative, right? So here I have considered that the electric lines of forces are departing from the positive charge. So you see, let us consider a point here, a point P, a point Q, and a point R. These 3 points are considered to be in as same potential, that is equipotential. From the name itself you can understand equipotential, that means equal potential. The potential of these 3 points are 0. So difference in, now if you displace a charge from point P to point Q, or from Q to P or Q to R, the potential required will be here 0, because they are in the same potential. So this is the meaning that it is an imaginary surface joining the points of same potential in an electric field. So in an electric field, in the same electric field, if there are 3 or more points, then the potential at that point will always be 0. So there are certain properties we will find that equipotential surface can never be point size. That means surface cannot be point size. Whenever a point object or point charge is producing an electric field around it, always it will be in surface area. Like if we consider to be as point charge, a source charge to be as point, then it will create a spherical electric field around it. So we'll consider this as equipotential surface, which is in spherical in shape. Now if I consider a line charge, suppose this is a line, it is having a positive charge around it, so it will create an cylindrical surface around it. So we'll consider to be as equipotential surface due to isolated point charge is spherical, that means always it is spherical. Equipotential surface due to line charge is cylindrical, that means always it will create a cylindrical shape. So this is the meaning of equipotential surface, which determines that what is the surface, whether it is being formed by point charge or whether it is formed by a line charge. A surface can be spherical in shape or it can be in cylindrical in shape. It based upon the source charge. If it is point charge, if the source charge is point, then it will create a spherical shape, and if it is in line charge, then it will create a cylindrical shape. But to understand that how much flux is going to come out from a surface, then we will be calculating with the help of Gauss theorem or the Gauss's law. Gauss's law says that suppose we have a source charge and an electric field is around it, so number of electric lines of force which is departing from the source charge is equals to integral multiple of that flux. Means total flux emerging from a surface is equals to total charge enclosed in the surface to that of epsilon naught. That means 1 by epsilon naught times the total charge enclosed in the surface is the electric field or the total flux coming out. So here you will find that the electric flux over an enclosed surface is 1 by epsilon naught times the total charge enclosed by the surface. That means if I say here it is d phi, that means what is the change in flux, and if we integrate, then directly we will be getting here total flux coming out of that surface. That means here if this was the surface in spherical shape and positive charge were here, how much flux is coming out from this surface? That is total flux is equals to line integral of electric field over a closed surface. Line integral of electric field over a closed surface is equals to 1 by epsilon naught times the total charge enclosed in that surface. That means whatever may be the charge inside the surface, 1 by epsilon naught times that amount of flux will be coming out. Now if I consider it to be as Q, then if in a Q there is a Q charge, Q amount of charge, that means how much flux will be coming out from it, that is Q by epsilon naught. And if I say how much electric lines of force or number of lines are coming out from one face of a cube, that means we know there are 6 faces of a cube, 6 sides of a cube. So from one face the total flux will be Q by 6 epsilon naught. Okay, so this is the meaning of total flux emerging from a surface, means 1 by epsilon naught times the total charge enclosed in that surface. So this is Gauss law. So here I have noted down one numerical. So this is just a basic numerical of this chapter, which shows a relation between a charge and its integral multiple. Like for example, if I say Q equals to Ne, we know this is the quantization of charge. So a surface contains how many charge, what is the total number of charges, and if the number of charges are numerous, so we quantize it and we say that Q equals to Ne. So here we will read the question. A polythene piece rubbed with wool is found to have a negative charge of 3.2 into 10 to the power minus 7 coulomb. So here charge of a polythene that is Q equals to 3.2 into 10 to the power minus 7 coulomb. Okay, this is the charge. And we have to calculate the number of electrons, that means N we have to calculate here. And electrons we know it is 1.6 into 10 to the power minus 19 coulomb. So this is the value of one charge. So from here we can easily calculate what is the number of electrons. So N equals to Q by E. Q we have 3.2 into 10 to the power minus 7 by 1.6 into 10 to the power minus 19. So if you calculate here, so 32 into 10 into 10 to the power minus 7 and 16 into 10 into 10 to the power minus 19. So what I have done here, you see, I have removed the point and the 10 comes down, and on removal of this point after one digit again 10 goes up. That means this 10 and 10 got cancelled. So 16 to the 32, and here 2 into 10 to the power minus 7 and this 19 will be coming up. So here we will be getting here 2 into 10 to the power 12. Okay, so number of electrons getting transferred is 2 into 10 to the power 12. So we have cancelled out, and last expression or last value which we got, that is N equals to N equals to 2 into 10 to the power 12. Okay, so this is what we have done. What is the amount of mass transferred? That means total mass transferred equals to mass of a single electron into number of electrons. So mass of a single electron we know that is 9.1 into 10 to the power minus 31, and number of electrons getting transferred is 2 into 10 to the power 12. So when you multiply here, we will be getting 18.2 into 10 to the power minus 31 plus 12, that is bases are same, power will get added up. 2 into 10 to the power minus 18 kg. Okay. So here I have noted down two questions which you will be solving in your exercise book. So in both the formulas you will find that we have to use the formula of Coulomb's law, that is F directly proportional to Q1 Q2 by R square. Or in the previous video you will find that also I have given one formula 1 by 4 pi epsilon naught Q1 Q2 by R square. In both the numericals you will find that distance is mentioned in the question, both the charges are also mentioned, and 1 by 4 pi epsilon naught can be taken as 9 into 10 to the power 9. Okay, these values you can take, that is Newton meter square per coulomb square. So this is the value of 1 by 4 pi epsilon naught. Okay, so I hope that you will be writing in your exercise book, and time to time, if possible, you will send me your notes converting into PDF file in my email. Okay, so I can cross check whether my students are doing or not.